Okay, now we're about 10 years later, in 1969. And in 1969, two fellows, Minsky and Papert, wrote a book. And the book actually states that there's many limitations with the perceptron. Yeah? Actually, this book let the funding dry up. Yeah? Suddenly, we faced our first AI winter just because there was no R&D funding anymore flowing into machine learning, especially perceptron and neural networks. One of the best known issues with perceptron is the XOR problem. The XOR is a logical port, and it's called an exclusive OR port. And the exclusive OR port is only one when both inputs are the same. So this is a binary case. So if we have 0, 0, 0, 1, 1, 0, and 1, 1, yeah. If we look at the output, this is only one when both in and output are the same. The other cases is 0. This is how we define this logical port. So if I have, and let me put this in red, and then the 0 points we put in black. Okay. So we have, assume this is 1 here, this is 1 here. Yeah. In black we have these 2 points. Yeah. Okay, when one of the two is 0, yeah, so this is the actually in 1 and in 2, okay. So there's 0 when one of them is 0, and they're 1 when both of them are the same. So this is gonna be this. This is how you visualize a XOR port. Now you can do whatever you want. You cannot find a line that separates the black dots from the red dots. It's just not possible. So the only way to separate these points is, by having two hyperplanes. Which basically means that there is a need for non-linearity. This is basically the biggest conclusion of this XOR exercise. So when we talk about non-linearity, we have two options. We're gonna work with, and basically we're gonna combine it. We're gonna look at hidden layers, and we're gonna look at activation functions. Okay? Hidden layers automatically means that you have more than one layer. Yeah? You have basically a hidden layer here. You have an output and you have an input, x1, x2. Yeah, and they go in here, they go in there. Yeah? Like this, so this is the hidden layer. But the hidden layer by itself does not give you the nonlinearity. Yeah, if we would call this one, if this we would call H1, this would be H2, and this P1 with W1 and W2. Yeah, then P1 equals, so there is still a bias term B3, here is a bias term B1, here is a bias term B2. So P1 equals W1 H1 plus W2 H2 plus B3. Yeah. And H1 by itself equals, so let's call this W11 and W12. H1 is W11 X1 plus W21 X2, yeah, and the same for H2, yeah. H2 is W21 X1 plus W22 X2. Okay, but what you see here is still linear, huh? So just adding a hidden layer is not enough.